expression for capillary rise or fall. So up to which height liquid rises in a capillary or up to which depth liquid falls in a capillary, that formula we derive. But that formula we derive using the two methods, one using the pressure difference, another using the force, or we say the weight. First we say the capillary rise using the pressure difference. It is the simplest method to calculate the formula to, for rise of liquid in a capillary. Suppose a capillary is deep inside liquid present in a beaker. In a capillary, water rises up to the height h. This is a free surface of liquid in beaker, and up to this point water rises inside the capillary. That distance is known as height of raised water. So this is a concave surface, and because of that concave surface there must be the pressure difference, that is air pressure and inside pressure. That formula we have calculated. So pressure difference due to the concavity, that is 2T upon R. So liquid rises inside the capillary up to the certain height. So that liquid column also apply the pressure on point inside the liquid. We consider the point here, later point, that is A. So we calculate the pressure due to this liquid column at point A. So pressure due to the liquid column of a height h, we know the formula, that is h rho g, where rho density of a liquid, g acceleration due to gravity. H height of liquid column, rho density of liquid, capital R radius of concave liquid surface. This causes concave liquid surface. If you extend it, it gives a circle, and it has a radius, and that radius we denote by capital R. Small r radius of a capillary. Theta angle of contact of a liquid. Using the diagram, we write the formula for cos theta. Cos theta is nothing but small r divided by capital R, and from this capital R is equal to small r divided by cos theta. Substitute that value in the formula. We are substituting the value of capital R. Then we get h is equal to 2t cos theta divided by r rho g. It gives rise or fall of liquid in a capillary. If the tube is narrow, then the rise or fall of liquid is large. So this formula is easy to derive. Just you remember this one formula, h rho g is equal to 2t upon r, and second formula cos theta is equal to r divided by r. From that capital R is equal to small r divided by cos theta, and substitute in above equation, then we get the formula for rise or fall of liquid in capillarity. Now we consider the second method. Again we consider the one end of capillary dip into the liquid. Liquid rises in a capillary up to the height h. Now the liquid inside the capillary is in contact with the inner wall of the capillary, which is in the form of a circumference. So length of a liquid in contact inside the capillary is equal to circumference of a inside circumference of a capillary, which is equal to 2 pi r. Force due to the surface tension acting along the tangent. So this is a force along the tangent, that is Ft, but That force is nothing but surface tension into circumference. Surface tension gives you the force acting on unit length. So here total length is a 2 pi r. So we consider the total force acting on the liquid over the free surface of a liquid inside the capillary and which is in contact with the inner wall of the capillary, and that force Ft is equal to capital T into 2 pi r. We consider the only vertical component which is pulling the liquid upward direction. If you join this line, then we get a triangle. From that we calculate this vertical component which is Ft cos of theta. So vertical component of Ft which is equal to Ft cos theta. Substitute the value of Ft, that is capital T, inside bracket 2 pi r bracket complete cos theta. Now the second part of it, we consider the volume of a liquid in a capillary rise. So this is the liquid. We calculate the volume of this liquid present in the capillary. So for that it is a cylindrical in shape. So volume of a cylinder is nothing but pi r square h. We know the formula for density, which is mass upon volume. From that we calculate mass of a liquid, that is density into volume. Now volume, that is pi r square h. Substitute that. So pi r square h into rho gives you the mass of a liquid in the capillary rise. This liquid apply the weight in downward direction. So weight of the liquid in the capillary rise or fall is equal to mass into acceleration due to gravity. Mass is pi r square h rho into g. This weight, total weight of a liquid inside the capillary is balanced by this upward force, that is vertical up component of Ft. So we equate both, equating equation 1 and equation 2, that is weight of liquid in a capillary is equal to vertical component of Ft. Substitute the values, then we get h is equal to 2t cos of theta r rho g, which is similar to that of a previous formula. So we can calculate the formula, that is rise or fall of liquid in a capillary by using the two methods, and we get the same formula. Fluid in motion, flow of water through tap, flow of cooking gas through a tube or through a pressure cooker, flow of water through a river. These are the types of motion of a fluid. Which are the different points related to the motion of fluid? First, hydrodynamics. It is a branch of physics which deals with the study of properties of a fluid in motion. So it is one branch of physics where we study the properties of fluid. Steady flow, measurable property of a fluid at given point is a constant over time, like pressure, velocity remain constant. What is a steady flow? We see the flow of a liquid or water. So water is now flowing in this direction. We divide the water in different layers, and velocity of each layer remain a constant throughout the path. Then that type of a path is called as a steady flow. Velocity may be changed from layer to layer. The topmost layer move with higher velocity, below layer move with less velocity than the topmost layer, and the velocity slowly go on decreasing toward the bottom side of the liquid. But each layer move with constant velocity. That type of flow is called as steady flow line. It gives the path of an individual particle in a moving fluid. If you consider the particle here and we observe its path or its direction, so it take this path, that path is called as a flow line. That is a line which indicate the path of the individual particle in a moving fluid. Streamline. In curve type of flow of a liquid, tangent at any point is in the direction of velocity of the flow at that point. What is a streamline? Suppose water is flowing and suddenly it is a fall in downward direction. This is the path now, and here it is start falling in downward direction, taking a curve path. At that times, at this point, when you draw the tangent, this tangent gives you the direction of velocity, and that line is called as stream line. In a steady flow, streamline and flow line are identical, but in a curve flow, this is the flow line and this is your streamline. This is different. It indicate the your flow line and it indicate your stream line. So in case of when the moving fluid take a curve path, then flow line and streamline are different. But when the liquid is flowing with a steady path in one direction, then streamline and flow lines are constant. Flow tube. It is an imaginary bundle of flow of lines bounded by an imaginary wall. So if you consider some area in this flow where we see this streamline and flow lines bounded by this area which gives you the bundle of lines. This is called as your flow tube. Flow tube is in adjacent flow tubes cannot mix. So two flow tubes are different, not mixed with each other. Laminar flow, streamline flow. Laminar flow or streamline flow, it is a steady flow of a liquid. In a steady flow of liquid, adjacent layer of a fluid move smoothly over the other. Example, steady flow of a river. When the river is flowing with steadily, so that path we have shown here, it is moving steadily. Each layer move with constant velocity, and that type of flow is called as laminar flow or streamline flow. Topmost layer move with the highest velocity and bottom layer move with less velocity or slowly. Also in other case, if you see the river is flowing, then the layers near the bank of both side of river, the layers move with slower velocity. As you start moving towards the center of river, velocity go on increasing. The water near both sides of river bank move with slower velocity, and as we start moving from the both side banks towards the center of a river, velocity of each layer go on increasing and a central layer move with the highest velocity. But each layer move with constant velocity, and velocity of each layer does not changes as the time passes. So this type of flow is called as streamline flow or laminar flow. But in case of when the that same river take a turn, at that path velocity of each layer go on changing, and this type of flow of liquid is called as turbulent flow. It is a flow in which flow rate is very high and the flow pattern changes continuously. That means the same rivers when converted into flood, then the path or speed of water in a river does not remain constant, changes continuously as the speed of each lever changes rapidly and continuously. Then that type of flow of liquid is called as turbulent flow. Critical velocity, the velocity beyond which streamline flow becomes turbulent, is called as critical velocity. When the rainfall is less, then the rivers start flowing with a steady velocity. It is called as streamline velocity. If a heavy rainfall takes place, then the velocity of this water suddenly changes and move up and down, and the water start flowing in this way. The velocity get changes. Streamline now converted into the turbulent flow. The velocity after which this streamline convert into turbulent flow, that particular velocity is called as a critical velocity, beyond which now the water flow in a turbulent path. To calculate the critical velocity, we use a formula Vc is equal to Rn eta divided by rho into t. Its proof is out of syllabus. Rn is known as Reynolds number. Eta is called as coefficient of viscosity. What is the coefficient of viscosity? That part we see afterward. Rho, density of fluid. D, diameter of tube. Whatever we see related to the water, that same you see related to the flow of gas also. So in a air, different layers move with different velocities. In a summer, we see the storm. This storm is because of a different velocity of the air layers. Reynolds number can be calculated. Rn is equal to Vc rho into d divided by eta. Reynolds number is a pure number. Reynolds number is unitless and dimensionless. This Reynolds number gives you the flow of fluid is whether streamline or turbulent. If the value of Reynolds number is less than 1000, then the flow of fluid is known as streamline flow. If the value of Reynolds number is in between 1000 to 2000, then that flow of fluid, that may be the liquid or gas, is called as unsteady. And if the Reynolds number Rn is greater than 2000, then the flow of fluid, it may be again liquid or a gas, that flow is known as turbulent flow. Viscosity, when fluid is in motion, resistance between the layers of a fluid opposes to the motion of a fluid. This internal resistance between layers of fluid to the flow of a fluid is due to a property of a fluid called as viscosity. It is similar to that of resistance related to the electricity. When the current passes through the material, then material opposes to the flow of a current, and that opposition we say that resistance. Similarly, when the liquid start in moving, each layer opposes to the other layer. So motion of each layer of a fluid is opposed by the motion of the other layer. So topmost layer having highest velocity v plus dv and lowest bottom layer having the lowest velocity. So velocity go on increasing as we move from bottom towards the top part of a flow of a liquid. So each layer opposes the motion of the other layer. So this opposition to the flow of each layer is equivalent to the opposition to the flow of a current. In current electricity, we say the name to that as a resistance, and in a flow of fluid, we give the name as a viscosity. That is, viscosity is nothing but opposition to the motion of each layer called as viscosity. The property of a fluid by virtue of which relative motion between different layers of a fluid experiences dragging a force, that is opposition force. That dragging force is called as viscous drag or viscous force. The tangential force which opposes the relative motion between the different layers of a liquid is called as viscous drag or viscous force. Viscosity is a property. Because of that, each motion of each layer is opposite, and by which force it is opposite, that force value is called as viscous force. In liquid, viscous drag is due to the molecular cohesive force. In case of gases, viscous drag or viscous force is due to the collision between the fast moving molecules. That is, fast moving molecules opposes the motion of the other molecules. Viscous flow and non-viscous flow. We see the difference between them. In a viscous flow, dragging force is present. In non-viscous flow, dragging force does not present. In viscous flow, different layers move with a different velocity, just like shown in a figure. So this is a pipe, and in pipe, the flow of water is shown. So middle layer move with faster velocity than the layers close to the pipe, inner surface of a pipe. In a non-viscous, all layers move with the same velocity. There is no change in velocity of different layers in a non-viscous flow. Third, viscosity is not zero, but in non-viscous flow, viscosity is zero. Example, viscous flow, water or oil. Non-viscous, liquid helium at 2 Kelvin temperature. If we take water from a bottle in a spoon, it flows freely and quickly. And if we take a syrup or honey from the bottle into the spoon, it flows slowly and stick to the spoon. This difference is due to the fluid friction or fluid viscosity or fluid resistance, different resistance between the different layers. This property of a fluid is called as viscosity. So each layer opposes the motion of the other layer. That property is called as viscosity. Observe the flow of river water. Water near the both sides of a river bank flows slowly. At the center of river, velocity of water is larger. As we move from river bank towards the center of the river, so velocity of a flow of water go on increasing. At middle portion, velocity of flow of water is largest in a river. थोडक्यात फ्लुइड इन मोशन, नळामधून पाणी बाहेर येणे, कुकरमधून पाण्याची वाफ बाहेर येणे, नदीमधून पाणी प्रवाही राहणे, हे जे आहे हे फ्लुइडच्या मोशनचे उदाहरण आहे. हायड्रोडायनॅमिक्समध्ये फ्लुइडच्या मोशनच्या प्रॉपर्टीचा विचार केलेला जातो. ही फिजिक्सची नवीन शाखा आहे, जिथं फ्लुइडचं जे मोशन आहे त्याचे जे प्रॉपर्टीज आहे त्याचा अभ्यास केला जातो. स्टडी फ्लो, त्या प्रभावामधील प्रत्येक पॉईंटजवळ जर मेजरेबल क्वांटिटीच्या मोजता येणाऱ्या राशी आहेत, क्वांटिटी आहेत, जसे वेलॉसिटी, प्रेशर यांच्या किमती जर कॉन्स्टंट राहत असेल, अशा प्रवाहाला स्टेडी फ्लो असं म्हटलं जातं. स्ट्रीमलाईन हे काय देतं, तर प्रवाह कुठल्या दिशेला चालला हे सांगायचं काम ही लाईन करते किंवा तो मार्ग दाखवायचं काम करते. स्ट्रीमलाईन एखाद्या पॉईंटजवळ टँजंट काढला की टँजंट काय देते, प्रवाहाची दिशा दिसते. एकाच दिशेने पाणी जात असेल तर ही स्ट्रीम लाईन आणि फ्लो लाईन एकच असतं. पण ज्यावेळेस वक्र पाणी येतं किंवा धबधब्यासारखं पाणी पडायला लागतं, तर धबधब्याच्या ठिकाणी टँजंट काढला तर टँजंट सरळ जाईल आणि सरळ जाणारा हा काय दाखवतो, तर स्ट्रीम लाईन दाखवतो, आणि वाकडं जे पाणी दाखवतो ती दिशा दाखवते फ्लो लाईन. म्हणजे स्ट्रीम लाईन आणि फ्लो लाईन त्या ठिकाणी वेगवेगळ्या असतात. फ्लो ट्यूब म्हणजे प्रवाह जाताना त्याचा जर एखादा ग्रुप तयार केला तर या ग्रुपला म्हटलं जातं फ्लो ट्यूब. लॅमिनार फ्लो हा स्ट्रीमलाईन फ्लो. पाण्याच्या प्रवाहाच्या वेगवेगळ्या लेअरमध्ये विभागणी केली जाते. प्रत्येक लेअर ही जर कॉन्स्टंट वेलॉसिटीने पुढं जात असेल, तिला त्या पाण्याच्या प्रवाहाला म्हटलं जातं स्ट्रीमलाईन फ्लो किंवा लॅमिनार फ्लो. ज्या प्रवाहामध्ये प्रत्येक लेअरची वेलॉसिटी बदलत जाते, थोडं अंतर गेलं की वेगळी दिसते, परत अंतर गेलं की वेगळी दिसते, अशा पाण्याच्या प्रवाहाला म्हटलं जातं टर्ब्युलंट फ्लो. ज्यावेळेस कमी पाऊस पडतो त्यावेळेस नदीचा प्रवाह हा शांत असतो, तो झाला तुमचा स्ट्रीम लाईन किंवा लॅमिनर फ्लो. पण जास्त पाऊस पडला तर ती नदी उसळी मारून खळखळ व्हायला लागते, तो जो प्रवाह आहे त्याला म्हटलं जातं टर्ब्युलंट फ्लो. वेलॉसिटी, कमी पाऊस पडला तर सुरुवातीला नदी अशी शांत तुमची वाहत असते, आणि जसं पाणी वाढत जाईल, जादा पाऊस पडत जाईल, तसं हळू पाण्याचा वेग वाढत जातो आणि ठराविक वेळेनंतर पाणी असं उसळी मारून पुढे जायला लागतं. जी ठराविक वेलॉसिटी मिनिमम होते की त्यानंतर ही उसळी मारून पाणी जायला लागलं, ती मिनिमम वेलॉसिटी म्हणजेच तिला म्हणलं जातं क्रिटिकल वेलॉसिटी. या स्ट्रीमलाईन प्रवाह ज्या वेलॉसिटीनंतर टर्ब्युलंट फ्लोमध्ये रूपांतरित झाला, त्या शेवटच्या स्ट्रीमलाईन व्हेलॉसिटीला म्हणलं जातं क्रिटिकल व्हेलॉसिटी. ते काढायचं सूत्र इथं दिलेलं आहे. त्याच्यावर तुम्ही रेनॉल्ड नंबर काढू शकता, आणि ह्या रेनॉल्ड नंबरची किंमत तो प्रवाह स्ट्रीमलाईन आहे किंवा टर्ब्युलंट आहे हे सांगायचं काम करतो. पाण्याच्या प्रवाहातील प्रत्येक लेयर ही वरच्या लेयरच्या मोशनला विरोध करते, किंवा वरची लेयर खालच्या लेयरच्या मोशनला विरोध करत राहते. त्यामुळे प्रत्येक लेयरची व्हेलॉसिटी ही वेगवेगळी असते. सगळ्यात खाली जमिनीला स्पर्श केलेलं जे पाणी असतं त्याची व्हेलॉसिटी सगळ्यात कमी असते, आणि सगळ्यात वरच्या पाण्याच्या लेयरची किंवा फ्लुइडच्या लेयरची व्हेलॉसिटी सगळ्यात जास्त असते. प्रत्येक लेयर दुसऱ्या लेयरच्या मोशनला विरोध करतो, ही त्याची जी प्रॉपर्टी आहे त्याला म्हटलं जातं विस्कॉसिटी. आणि ज्या फोर्सनी तो विरोध करतो, ज्या ताकदीनं तो जे विरोध करतो त्याला म्हटलं जातं विस्कस ड्रॅग किंवा विस्कस फोर्स. लिक्विडमध्ये विस्कस ड्रॅग कशामुळे असतो, तर डिफरंट मोलेक्युलरमध्ये असणाऱ्या मोलेक्युलर फोर्समध्ये, ज्याला आपण कोहेजिव्ह फोर्स असं म्हणतो. आणि गॅसमध्ये का असतं, तर प्रत्येक मोलेक्युल मोशनमध्ये असल्यामुळे एकमेकाशी कोलिजन करतात, कोलिजनमुळे हा विरोध असतो किंवा विस्कस फोर्स प्रेझेंट असतो. विस्कस फोर्स आणि नॉन विस्कस फोर्स असे दोन प्रकार पडतात. ज्या ठिकाणी प्रत्येक लेयरच्या मोशनला विरोध केला जातो त्या ठिकाणी विस्कस फोर्स हा प्रेझेंट असतो, त्या विस्कस फ्लोमध्ये विस्कस ड्रॅग प्रेझेंट असतो. अशा लिक्विडचा प्रभाव की ज्याच्यामध्ये विस्कस ड्रॅग प्रेझेंट नाही किंवा विस्कस फोर्स प्रेझेंट नाही, त्याला म्हणलं जातं नॉन विस्कस फ्लो. विस्कस फ्लोमध्ये प्रत्येक लेअरची वेलॉसिटी वेगवेगळी असते, त्याची वेलॉसिटी वेगवेगळी असते. नॉन विस्कसमध्ये प्रत्येक लेअरची वेलॉसिटी कॉन्स्टंट असते, एकाच वेलॉसिटीने ते पुढं जातं. इथं अपोजिशन फोर्स नाही, म्हणजेच विस्कॉसिटी ही शून्य असते. इथं अपोजिशन फोर्स प्रेझेंट आहे, ती विस्कॉसिटी प्रेझेंट असते. उदाहरणार्थ, पाणी एखाद्या बाटलीतून तुम्ही चमच्यात ओतायला लागला की ते पटकन खाली येतं. पण त्याच बाटलीतून जर तुम्ही सिरप भरलं असेल किंवा मध भरलं असेल तर बाहेर पडताना ते हळूहळू पडतं. कारण की सिरपमध्ये किंवा हनीमध्ये विस्कॉसिटी म्हणजे लेअरला विरोध करण्याची क्षमता ही जास्त असते, तो गुणधर्म जास्त असतो, पाण्यामध्ये कमी असतो. नदीमध्ये सुद्धा बघितलं तर नदीच्या कडेचे लेयर जे असतात ते कमी वेलॉसिटीने चाललेले असतात, पुढं जात असतात. आणि जसं जसं तुम्ही नदीच्या मध्यभागाकडे जाल तसे वरचे मधले लेयर्सचे जास्त वेलॉसिटीने पुढं जाताना दिसतं. म्हणजे सेंटरमध्ये वेलॉसिटी जी असते, पाण्याची वेलॉसिटी किंवा प्रवाहाचा वेग सगळ्यात जास्त असतो आणि कडेला कमी असतो.